There's one more page on the handout for transformations, and we're going to take a look at it right now. This material is optional and not part of the course, so you can skip this if you want. I included this vocabulary because some teachers do want students to know it, so you can take a look if you'd like, but you're not responsible in my course for it, even in odd functions. So there are two special kinds of functions, even functions and odd functions. Even function, an even function, satisfies the property that f of minus x equals f of x for all x in its domain. Graphs of even functions are symmetric about the y-axis. An odd function satisfies the property that f of minus x is minus f of x for all x in its domain. Graphs of odd functions are symmetric about the origin. So I want to give you just a couple pictures here. First, just a picture of an even function. And so what does this business mean about f of minus x equals f of x? It's really related to the idea of y-axis symmetry. So here's an even function, here's x, here's minus x. If f of minus x equals f of x, that's like saying the y-coordinates of these 2 points on the graph are equal. So for any x, any opposite of x, you get the same y-coordinate. That's another way of saying that you have symmetry around the y-axis. And even functions always have that symmetry. For an odd function, the picture looks something like this. So the statement about this f of minus x equals minus f of x for an odd function. In an odd function, if you take an x in its opposite and you look at the points on the graph that correspond to them, for an odd function, we're saying the y-coordinates are opposite each other. So the f of x for this point and the function value for this point, which is f of minus x, are opposites. That's what this equation is saying. F of minus x is the opposite of f of x. F of minus x is minus f of x. So these two pictures sort of sum up the situation with an even function and an odd function and what that f of x business is saying. Some even functions are listed here on the handout. In fact, the name even function comes from the fact that even powers of x are even functions. Here's a graph I just made up of an even function. I just wanted to enforce that idea. It's not one of these, but this symmetry about the y-axis that any even function will have. Here are some odd functions. Odd powers of x are all odd functions. That's where the name comes from, and some other functions are odd functions too. And the graph of an odd function always has this origin symmetry. Remember, origin symmetry can be thought of as if you turn the picture upside down, the graph looks exactly the same. That's one way to interpret origin symmetry. So that's just, in a nutshell, a little bit about even and odd functions. No exercises, not part of our course.